I'm recording now, so this is the ds-incubator on the targets package, and today we're going to be talking in particular about one chapter of the book that is dedicated to understanding how functions, as opposed to a sequence of scripts, can help create succinct and clear pipeline. So in terms of the syllabus, the first time we met Will, then we walked through the walkthrough chapter of his manual in a very adapted way. And today it is also quite adapted, but the basic examples that the book shows are pretty much the same. My focus today is mostly not so much in like the kind of the all the tricks that targets can do for us, but mostly on how we as analysts in 2 degrees can basically shift from the structures that sometimes we have in our projects, which are kind of based on this kind of sequence of files, to a structure that is basically a bunch of functions that we call and are easier to express. So you will see that in the chapter, he does refer to sequences of scripts in this way that might be very familiar to many of us, and how you can move to a better place, basically, at least better in terms of how targets has an opinion about how targets are structured. So let's jump to our studio. The first thing I would like to show you is this R folder of the targets repo. So remember, we are working on a repository called ds-targets in our 2 degrees investing organization, and in it now I have pushed, like a few minutes ago, this version that has the materials of today. So in the R folder, I have a demo of the structure that corresponds to running an analysis as a sequence of scripts. So let's click on each of those just to have a quick look to see what they look like. It is very simple. This is pretty much the example that comes from the book. We are not solving any interesting problem here. It's just to understand what we mean by this kind of structure. So here, for example, the file is called 01 data. It is supposed to be the first file to be sourced, just to be self-contained. It is also calling packages in here. So it's attaching the tidyverse, and then it's reading a data set from the folder data. First, creating this little path, and then using that path to read the data. And then with that raw data, basically, we do a little bit of a transformation, replacing NAs with the mean of basically imputing NAs with one algorithm, if you will. And finally, saving the processed output in a new data set, a new object. So I arbitrarily chose a folder for storing such objects. Basically, you can think of this as a cache, where the expensive computations, we can avoid expensive computation by reusing that cache. So that's kind of very manual, and we are not leveraging the power of any system. In this case, it's like doing it very manual. So I could source this file, and that should, as an output, it should create a file here in the objects folder. So just to show you again, if you got lost, if I lost you here. So this is the root of the project. I have an empty folder called objects. So if I source this file, I would expect something to appear there. Basically, the output will be a clean version of that raw data. So here you are. So I just clicked source, and here is the data set. So just basically to kick off with the familiar ground, we know what this looks like. So I'm going to move a little faster now. I click in R, and I'm going to just show you a few other files. So this analysis is made up of 3 scripts: number 1, number 2, and number 3. Number 2, all it does is now it takes the input from the object, basically uses that manual cache that we created. and does something on top of that. So in this case, what it's doing, I mean, the only meaningful line in this script is this one here, where it is taking the data set that we cleaned in the previous step and then applying a linear model. And then again, it's kind of saving as an output that file. So I can source this now, and I should see my objects folder populate with a fit RDS file, which is this one here that I'm defining. And finally, step 3, which what it does is creates a plot for the data set as well, for the clean data set. So basically, in all this script, what matters is this. So these things that I'm highlighting here, eventually, we are going to convert them into functions to follow the opinions of the targets package and see how that kind of fits in a targets pipeline. But before we do that, I would like to show, okay, what we could do if we wanted to report an analysis that depends on those scripts. We would usually do something like this. We create a new file, maybe an R file on the root of the project, and we source each of those files one at a time. Here I'm using the function here from the here package, which is kind of clever about where to find things. I'm not going to comment too much on that because that's not the focus of today, but I'm just going to use it. And I'm not just sourcing the files, but at the same time, I want to kind of create a report. So I want to report on what those files do. So I'm also kind of calling the objects that those files create. For example, the number 1 script creates an object called dataset. So in my report, I'm actually printing dataset because I want to see what it looks like. So same thing. This is kind of a glue. A report is basically a glue for a bunch of objects that we have created in other files. So again, I could also source this file and it should work. Basically, it's just calling each of those scripts. And also interesting, I don't know if you knew, but you can also click here to knit an R file similar to what it could give you if you were knitting an R Markdown file. So let's just do that for fun. Basically, what that produces is an HTML version. Well, you can choose among other formats, PDF and so on. But here I'm just basically creating a report from this analysis or this glue analysis type of R file. So here it is, the day of today, my name, somehow it appeared there. I don't know where it comes from. I guess that's from my root, maybe from here. So here's my report. This is the result of rendering that report. Looks good to me. It's useful. I can communicate my science. But basically, I want to show how separate are those steps of basically creating the objects which we're creating in this file, and in this file. Those are steps that we could do ahead, and we could create, all those objects. We could save them in the manual cache that we created, and then we can use those cached objects in a report like we are doing here, right? So we are getting dataset, feeds, and hist. So if I have all those computed, I could even skip the calls to source and directly do calls to kind of read from the folder where I have all the objects created. So that is a little bit what happens in a more formal way with the targets package. So let's move on to a bit more of a sophisticated way of reporting these objects that we created manually. So one level up in complexity and in coolness, in my view at least, is using an R Markdown file, which again, you're familiar with this, so I'm gonna just show you the bones of this file. It has the exact same steps. Let's see if I'm using, no, actually it looks like I kind of messed up with the names. I think the one I want to show you has the opposite. Yeah. Funny enough. I chose the wrong names for the different files. So the report that is called report targets actually is not using targets, and the report that does not have the suffix targets does use targets. Anyway, I'll fix that. So for the moment, forget about the name at the top of the file. So basically, this is an R Markdown file. Most of us are familiar with it. I choose the GitHub document output format just because I like it. That it gives me a beautiful website on GitHub. I set up some options here just because I like them. I'm using the packages that this analysis needs. Maybe, I think this is an advantage to using the packages in each of the script that needs them, because it's more transparent. Also, instead of calling, say, the tidyverse 3 times, 1 per script, we call it just once in this report. And it's very obvious, which packages we are depending on in this analysis. So that's it. Then I'm sourcing a file called functions. That file, just for an example, but also to show this file called functions has this helper function here, which I created to simplify the process of sourcing every file that lives in the R folder. So here we are. So I'm sourcing those functions, so they are available to me. That this call here gives me access to this custom function here, source all. So when I run this line number 33, every R file in the R folder will be sourced, and that means that the objects that those files created are now available to this R Markdown to display, right? So here I'm printing the output of datasets, printing the output of feeds, and printing the output of hist. So let's knit this report. So this could be then, to summarize what I'm doing, this is the second way to report an analysis, but it is still based on a sequence of scripts as opposed to a target's function pipeline. So that's our next step. We'll get there in a moment. So here is our report. This is what it looks like. It's very similar to what we saw before, just maybe a little clearer. And in a different format. Before we did it in HTML, now we are doing it in MD Markdown, which then GitHub transforms into an HTML website for us, web page for us. So now the third step is going to be to take each of those scripts and transform them into a function that we can call in a pipeline. So how do we go about that? Well, easy. So basically, the whole script. Let's start from here, from the whole script. We could go to a file called functions where we define all functions. And the first one that we're gonna do is this one here. It's called read and clean. But I have it there as a cheat sheet in a way, but let me just paste the source code here. So this is where we started, right? And this is, let me clear this up a little bit. And this is with what we are gonna end. Why is this shorter? Well, because there are some things that we need and some things that we don't need in a function. So here, this path that we have hard-coded in our function is just an argument to the function, right? So we won't need this. This call to read CSV is there, right? So it's this line here. So this line, basically what it did, it just moved there, right? And then the core of the function. So when we have that data set there, then we have this, right, which is essentially this that you see here, except that we are not assigning the result to an object, because R by default will return from inside the function the last thing that it's kind of computed inside. So this is what kind of moves in here. Right, so that's the body of our function, and then we don't need to save it to anything. So that's great as well, because we save a lot of code. Like each line of code or each character that you type in code is a liability, something you have to maintain, something that can have bugs. So in this case, we can rely on targets to know where to store that object that will be the output of this function. So we don't need to say it explicitly. And then we don't need also the call to library, because targets will know. There is a specific place in the targets options where we say which packages my targets need. So this is how we end up with the function that reads and cleans the data. And same thing with the other two scripts. So this was a script when it was just a script. But from this, the only thing that we really care about is this line here when we create a model. Then, inputs and outputs I/O are not interesting, and they take up actually most of the code. So our, where is our functions file? Here. Our function file just, takes a data set that, is the result of a previous function and creates a model with it. And finally, our third script here, which, the interesting bit was the plot, creating the plot. Same thing here. So that's the only thing that survives. The rest was just dealing with inputs and outputs. We don't need it. So now with that, we have functions that do the heavy lifting of our analysis. So all we need to do is to glue them together in a report, right? So let's first look at, but remember, I mentioned that one thing is to create the objects, right? So to create that cache from which then we can pull things out and report them in as many workflows as we want. So here, for example, we have a model and we could create a report just to explain the model. And we also create a plot. So we could create another workflow just to report on that plot and discuss it. Or we could do one that integrates the two. It's totally up to us. But the creation of the targets, the creation of that, those computations that create those objects that we can then use in multiple reports are kind of two different steps. So now let's go to our next step, getting closer to targets, to the target's opinion about doing data analysis. And let's see, what we have here. This is also like a refresher from the previous session, which actually I forgot to discuss what other requirements for today. Really none if you find this informative. So I'm kind of walking through everything anyway. But last time we went a little slower. So if you're feeling lost, maybe you want to watch the video of last meetup. How did I create this file? When I used the function so I did first library targets, because now this file is a very formal file that targets requires. So once we are using the targets package, then we have access to all its functions, and there's this function called targets tar script that will create a script with a toy basically example, and that is exactly what we walked through last time. Then you could also use the function tar edit that will open the file that you're looking at right on the screen. So I started from there, but then I tweaked it a little bit to be the actual pipeline that I want to analyze, or I want to communicate my data science with. So let's briefly review the anatomy of a tar file. So it is called specifically _target.r. It must live in the root of the project, and basically you start with a call to library target, so all its functions are available to this script. Then there is a section where you refer to anything that is global. So for example, the functions that live in the folder are in the file functions, so we want them here. So this file has to have access to them. They are global, so they should be available in the global environment of the pipeline. So that's why we put it here in this first section. Also, I want to so in this particular case, the file functions has also the pipelines there. But if they were in separate files, as they were before, remember that the R folder has 01, 02, 03. You could also do something like this. I used that function. I created that function source all that on one go sources every function in every R script in R. So that would be a global that would also go there. Thank you, Jackson. Then also global is in this particular case. I decided to make when we attach the tidyverse, it's very verbose. So I'm saying, hey, be a little quiet. And that ends with this section of globals. And then we have some options that are global but within target. So basically everything that we pass inside the function tar option set will be passed to every single target in the pipeline, which are these ones here at the bottom, right? We could also set specific options inside each target. So you will see that the function tar_targets, this is a review again, also has, for example, an argument, you can pass packages specifically to this target. But in this particular case, we are passing all the packages to all the targets. And then finally, we have actually this, the targets themselves. So every targets file should end with a list of targets. And this is how we are using now the functions that we define. So what we're doing is, first, I think this is new, we didn't see this the last time. When you are using a file that is stored in your system, in this case, we want to read a file that is in the data folder, this one here. So the very first target in this pipeline, what it does is it looks into that specific path, right? Data row_data.csv, and basically creates a target that only contains a path. So this is what this particular target is doing. And we have to say this argument that I don't think we saw last time. You have to say format equals file. There's going to be a meetup pretty much dedicated to this idea of reading files and also to creating Markdown reports. So for now, I just want to give a glimpse to it, but I'm not going to dive very deep into it. And then the other targets, basically you have one target per step. Remember that we had before. The first step was to read and clean the data. And so this is the name of the target. You may remember from last meetup that every call to tar_target starts with the name of a target and then an expression. So in this case, the expression, what it does is uses our function, the function that we defined as read and clean. And which data set it takes? Well, which path it takes? It takes the path that is defined in the previous target. So this name comes here, right, is used there. And now the final two targets, now we want to feed a model. So we are going to store the object into a new target called target feed. So this is the name, and the expression is a call to the function that we define, and the dataset that we pass it is the dataset that comes from the target defined before. And once again, we repeat the process. Now we create a histogram. We call that object target hist, and we use the function create plot that we created. And the target that is the input of that function is the one that we defined, 2 steps above. So with this, I'm ready to do something like tar make, right? It's probably going to say that all the targets are going to be probably skipped, I guess, if I did run this before. Yeah. So it's saying that the targets are going to be skipped because I already ran the pipeline before. But if you changed anything, each of the targets that you change will be out of date and will be recomputed. So for now, I wanted to also review some of the coolest functions like target this network. I will show us a visualization to understand how the targets are connected to each other. It looks like it's messed up with something here. No idea what's going on. Interesting. Ooh, doesn't look good at all. And also it looks like it doesn't wanna restart. Maybe I'm gonna just kill this. And it's also a moment, luckily we're kind of close to the end, not quite what I wanted, but we can do the round of voices now probably while we ds targets, while we restart that. So the only thing, let's see if I can record from this quickly. I'll push it for, actually now we have to be finishing anyway. So the last thing I'm going to show is the report that uses the targets. So the targets have already been computed. So if I wanted to use the targets in an Markdown file, it is fairly straightforward. In this case, I'm calling the function tar_make, but if you know that they're already done, you don't need that. I'm attaching the targets package. In this case, I'm calling tar_make, and then I'm just using the targets with just by calling, for example, the function tar_read we discussed it last time, to read each of the targets and report on them. So if I need this file, it's rendering now. I'm going to show you the output, and we start with a round of voices here. There you go. So this could be a report that uses the power of targets. There is a better way to render reports actually using targets. So you basically rendering the R Markdown reports inside the pipeline, but that's something that's going to be the topic of another meetup. So just a quick look to see what this looks like. Reading the targets data and just printing it there. Exploring the structure of the fitted model and creating the plot. Okay, that was all that I have for you today. So I would like to ask a quick round of voices to see if there is any question or comment. So I see Jackson first in my list.
So I kind of see obviously this is useful if you have a large project and need or don't want to rerun the entire pipeline in every instance. But I'm wondering at what scale a project like this starts to make sense, and also in particular what size of data sets or you know what I mean? I feel like or if there are still benefits to structuring a project, to going through the headache of structuring a project like this. If the pipeline doesn't necessarily take that long to run and the data sets are relatively small, and especially at 2DI, if we have different kind of use cases, when it makes sense to maybe try to implement this, and when maybe it doesn't.
Yeah, I agree. I think that Will has, in the beginning, I think when he started with Drake, he was kind of selling it in a different way, but I think that he settled to saying, hey, if you're not doing long computations, it makes no sense, kind of. That's my impression. Probably we can discuss it with him too. But I think it's a very interesting point that you bring up, and probably one that makes these meetups useful, in that even if you decide not to use it, it's I guess that is something useful too. Alex?
Not too much to add. I think that in addition to anyone who's doing long computations, targets is still useful for anyone who is doing repeated computations, doing the same thing over and over and over again. Because it does change your mindset to think about the workflow rather than, I just have this script. So.
Good point. And I think that it's something that I'm still very beginner at. There is the power of something that he's calling dynamic branches and static branches that allow you to express extremely large number of processes in a very succinct way. So something that I could probably explore a bit more. CJ?
Just on this last bit, these tar read functions. So my impression is that if you made an RMD report like this, that ideally that would also be part of your targets workflow. So then I would wonder if this is really the recommended use of these tar read functions. I thought that they were more for the use of sort of debugging the process if it stops in the middle, rather than I'm creating reports. I thought that reports were intended to be part of the actual target script itself.
Yeah, maybe I misunderstood it. I will focus on the chapter about producing reports. I'll dig deeper, but my understanding is that the recommendation is to knit the report inside the pipeline using actually a function that comes from another package that is called target types. It's called tar render. But I think that within the R Markdown file, my understanding was that it is the way to actually pull those targets is to just call tar read or tar load. But I'll come back to that when I cover that. So thanks for kind of maybe exposing my gap there in understanding. Claire?
Cool. thanks, Mara. Yeah, I like how similar this example is to the real Pacta case that we've got in front of us. Yeah, I guess a question, maybe this is back to what CJ mentioned last week about this idea of when does the sort of cache reset on parameters, just to make absolute sure that if it realizes when you've changed a parameter, but maybe that's just a bit of a rookie question here. Otherwise, yeah.
Cool, thank you. Yeah, I
make a note.
I make a note to learn more about that and share the insights. Yeah, I'll show probably some examples. Jakob?
I don't really have anything to add. Was quite interesting, but yeah, I think like many good questions were asked, and I'm looking forward to hearing some answers. Yeah.
Thanks, Antoine.
Yeah, thank you, Mauro, for all this. And me, I'm not sure to understand about the Alex question about the repeated. I can't see how it helps for people who will use it repeatedly to use package. For now, that's something a bit unclear for me. For now, maybe if you can explain how it could help.
Yeah, I think probably yeah, Alex, go ahead. I think Alex was yeah.
Yeah. So really, it's moving from a mindset of I have this one big script that does everything, and maybe I jump around in different part of the script from here to there to try and get different things to work. Instead, you're moving to a mindset of I make one thing, I know that thing is correct, and then from there I move to the next thing. So it's the step-by-step process with the check at each step.
Okay, thank you.
I understand, because it is a new framework, it may take some time to digest. But it's great, to have these conversations, so I can also plan for spending more time in one or other aspects of the silos. And last person, Monica.
Yeah, I don't really have anything to add. I think it's a nice way to think in this way, and I agree with Alex that it's useful because then you have these contained parts of your projects, which is cool.
All right, thank you very much. Sorry, went over 4 minutes. See you next time.
Same, thank you.